the lineup, the speakers, the topics being discussed seem so cool. It seems like a really great conference.
Well, and I think with that, we're going to start the session. So that's a great kind of introduction there. Hi, I'll start with just introducing myself. I'm Cheryl Phillips. I teach data journalism and computational journalism at Stanford, including an investigative reporting class that Alex has been involved with in the past. Always focused on kind of data-driven and computational techniques. And so my job here is to simply moderate the session, but I also am just going to do a call out that I also run an organization called Big Local News, and we are a data sharing platform and collaborative, and we are trying to build news detection tools and resources, kind of infrastructure for local news. So if you're interested in that kind of thing, come talk to me. And what I'm going to do now is basically hand it over to Alex, who is joining us remotely. Alex Spangher is going to talk about surfacing newsworthy public documents as leads, and I'm particularly excited about this because I know part of this came from working with my class. So Alex will talk for a bit, and then we'll open up for questions from Alex. Because he's joining remotely, we'll do questions right after he talks, and then we'll switch over to Joris Veerbeek, who will be talking about news detection, kind of agentic news detection, am I right? And so we'll hear more from him about that, which I'm also really excited about the potential there. So I'll turn it over to you, Alex.
Great, thank you so much, Cheryl. And it's so great to be talking to you guys. I am so sorry I couldn't be there in person. I tested positive last weekend, and I was really disappointed and kind of erred on the side of safety. But it seems like such a great conference so far, and the talks seem so great. But please be in touch if you find any of this work interesting. I would love to continue talking, continue the conversation. Great, so I'm just gonna, can I share screens?
You should be able to.
It says the host has disabled participant screen sharing.
Oh, Libby's gonna come fix that for us.
Yep. And Alex, you do have I know the camera doesn't really show it, but we do have a good packed room for the fact.
I was trying to figure out how I could manage to show that for you, but there are people right out there.
We got at least like 20 folks in there, so you do have a crowd.
That's amazing. Hello, everyone.
All participants, you should be good to go.
Great. Thank you so much.
Thank you.
So this was joint work done with my advisors at USC and UCLA. This was also work that I did while I was doing a visiting year with Sridhar and Cheryl at Stanford. So I swear we didn't plan this, but I'm going to give another shout out to Cheryl's work. Cheryl's doing amazing work with Stanford Big Local and Agenda Watch, and we're going to talk about how this work kind of fits in or was inspired by that work as well. So yeah, a little bit about me. I'm a PhD student at USC. I'm a sixth-year PhD student now. And before that, I was working at the New York Times as a data journalist, data scientist from 2014 to 2018. So we all know this story by now, this story of, newsrooms are shrinking, becoming challenging to cover what newsrooms used to cover. And meanwhile, the raw material of government that is being produced that is worthy of coverage has stayed pretty much the same. And what that looks like, at least in the Bay Area, I just this morning pulled the meetings for the San Francisco Board of Supervisors for today, as you can for this week. As you can see, there are 8 alone on Monday throughout the entire day. So if you were a journalist for the San Francisco Chronicle, you might want to see what's going on in the Rules Committee or the Land Use Transportation Committee. But that's not all, because if you're at the San Francisco Chronicle, you might want to cover the broader Bay Area. And there are not just the San Francisco Board of Supervisors, there are also 8 other counties in the Bay Area, as well as a bunch of city councils that the CRON regularly provides coverage for. So clearly the volume of government documents in government meetings is quite tremendous. The goal for this project is to surface potentially newsworthy documents, newsworthy policies, newsworthy discussions from city council, from government. So we kind of assume if we have a stream of city council policies or a stream of local government topics to cover, and this can come from a bunch of places. I mean, Big Local News is doing great work with Agenda Watch, surfacing council policies throughout a large area. Council Data Project up in Seattle is an open source project that does the same thing. Crosstown is a project here at USC. Storyful, if you have some kind of stream of topics, it might become overwhelming to go through this stream. It might ultimately become not very useful for your news organization because clearly there's going to be a lot of stuff in this stream. There's a lot of stuff to pay attention to. So we would like to build algorithms and models that can rank, in this case, policies from more newsworthy to less newsworthy. So that you might say as a news organization, show me the top 10% of policies that were published in the past week in terms of the newsworthiness ranking, and I'll focus the most of my attention on these policies. Right? And so how we're going to go about that, obviously, is to answer this question, what is newsworthiness? This is a really vague and poorly defined question, and it differs per news organization. So, in the communications literature, there's plentiful citations kind of talking about public interest, people of distinction, surprising details, world context, all the kinds of reasons that scholars have identified why we might cover a policy. In this work, we're kind of going to sidestep these vague and amorphous criteria, and we're just going to ask a simpler question. Would a journalist have considered this to be newsworthy in the past? So our big bet, if we have enough data on what has been covered and what has not been covered, then we can build models. This provides us a very simple binary classification task. Either a document has been covered in the past or it has not. And we can use this to train predictive models for new information. I would say this, I would take a step back a little bit and talk about my research philosophy in general. As I said, I was at the New York Times from 2014, 2018. I learned some pretty hard lessons there, which was that, editors will not pay attention to anything that you do unless it's firmly grounded in their own decision making, if it is familiar to them, if it looks very similar to the kinds of things that they would do. Right, so that makes a lot of sense also. We don't want tech people just to come in and play with some prompts and trust what GPT can do, which has been trained on a corpora that we don't know what it looks like. We don't know the GPT corpora. We don't know a lot about their training details. I do believe that ultimately the tools that we build for journalists need to be grounded in training data that we can explain and that we know, and that that in some sense aligns with a particular news organization's values. Right, so this is kind of a larger branch of machine learning. It's kind of a subset of reinforcement learning that my work falls into. It's called imitation learning. And the general idea here is that we are looking at human actions at scale, and we are trying to learn them and replicate them even when they are not fully observable. So in this case, we cannot fully observe all of the newsworthiness decisions that are being made, but we are still going to try at scale to learn this system of decision making, and with enough data, we hope we can do it. So I'm going to talk briefly about how we detect newsworthiness in prior coverage, and then I'm going to talk about how we use that detection to create a training data set and ultimately train models. So the challenge with detecting newsworthiness, this task is put simply, which of these policies in the past have been covered by a major newspaper? So in this case, we're looking at the San Francisco Chronicle, and we're looking at policies published by the San Francisco Board of Supervisors. So the challenge with detecting newsworthiness is that a lot of policies kind of look the same. So here are two policies on trash can design and deployment that the San Francisco Chronicle published, I think in 2020. And here are two news articles about trash cans. If you were just looking at the word usage and the topics here, you might say that both of these policies got covered in both of these articles. But clearly that's not the case. Clearly, this article looks like it's actually covering this, whereas the second article doesn't seem to be about an actual policy. It's just about a fire in trash cans. So what we found was that traditional embedding models, traditional similarity models did a poor job of doing these comparisons. But what we developed was based on a classical model called the probabilistic relational model. And this model made it easier to actually make these connections. Because what a probabilistic relational model does is it models the explicit likelihood of a link between an article and a policy, or any two documents or any two items in a network, as a function of hidden variables. So these H's are hidden attributes, and by the chain rule and by marginal probability, you can actually develop explicit models for each of these hidden attributes. So I can ask very specific questions like, what's a hidden attribute about an article that might make it easier to link it to a policy? Does this article cover city policy at all? This article down here does not cover city policy. So if I were to learn an attribute that tells me, yes, this article is covering city policy, that might make it more likely that I could draw an accurate link between that article and an actual policy. So we did this for a bunch of hidden attributes, and we found actually that, so an attribute, does the article cover city policy? Does the article cover specific votes and specific policy considerations? Does the article cover recent policy? And we found that as we added more and more learned attributes to this similarity calculation, we were actually able to outperform state-of-the-art embedding model, similarity models at the time, with some more classical models like TF-IDF. And this was a little bit surprising, but TF-IDF captures a rich representation for each document. So we do feel like this combination of learned attributes is maybe steering us towards a space in TF-IDF where we're capturing more meaning and more data than maybe a dense representation might be capturing. Okay, so that's as mathematical as we'll get for this presentation. Basically, the bottom line is that with our methods, we can accurately predict when a city council policy has been covered by the news media. And that's pretty cool, because that gives us a very large data set of policies where we can say this policy has been covered and this policy has not been covered. So in the second part of the presentation, I'll talk about what we did with this data. So now, as I've established, we can pretty accurately say whether policy has been covered or not, and we can create a huge data set of this. So we created a huge data set of 10 years worth of San Francisco Board of Supervisor policies. About 10% of them, on average, had been covered. So that's a pretty high coverage rate, actually, compared to other cities that we've looked at. And about 90% of them have not been covered. In addition, we also took about 3,000 hours of transcribed video from the Board of Supervisors meetings, including 15,000 diarized speakers, including members of the public during public comment. So we started off with putting all of this information together and asking GPT, kind of testing the baseline. Okay, GPT, did this policy get covered or not? Would you cover this policy? How newsworthy is this policy? So we crafted a 3-part prompt where we described the policy, we described how it was being spoken about during the meeting, and then we also included the public comment period. So we particularly focused on what the public was saying about whatever policy it was. And there's a lot of details here that I'm kind of glossing over about how we parsed these city council meetings and identified members of the public and identified what the public was talking about. But for more information, you can see my paper. Okay, so now here are the results. So what we found, and this measurement is recall at 10. So if we recommended the top 10 city policies every week, this recall at 10 says that we have a 64% chance of recovering the 1 to 2 policies that were actually covered out of 60 to 100 policies per week that are usually introduced or discussed during city council meetings. So when we included the full prompt, which includes policy description, speaker information throughout the meeting, and public comment, we got this 64% accuracy. However, when we took away parts of the prompt, so when we took away public comment and when we took away transcriptions, our accuracy fell to about 30%. Sorry, our accuracy fell to 50%, and then without the policy description, it fell to 37%. Now, I want to point out that this is a fine-tuned process. So we fine-tuned GPT-3 to make these predictions. This is really important because then comparing this to just the pre-trained, out-of-the-box GPT, we find that pre-trained, out-of-the-box GPT has a much lower accuracy at detecting these newsworthiness considerations. And actually fine-tuning is really important. Collecting this data is really important, and observing this prior decisions really boosts our score. Finally, we evaluated these recommendations with professional journalists, and by professional journalist, I really mean one particularly cantankerous professional journalist who is currently at Reuters and says that he almost never considers recommendations useful, but he said that there was an 84% win rate against the baseline in that our recommendations were helpful. Now, I want to close on kind of an interesting exploration. I think you can easily make the argument that if all we're doing is modeling prior coverage and past topics, we are going to miss the new stuff. The first word in newsworthy is news, or the new stuff. And so we studied this directly. We said, how much does our training window affect what we are seeing? So we split up the training window from 2013 to 2021, and then we tried to predict newsworthy policies in 2022 and 2023. So if the trending topics in 2021 were really the most important things, then as soon as we reduced the training window and removed 2021, 2020, and so forth from our training window, we would expect to see a huge drop in accuracy. And we actually do. We do start to see a big drop, but it really does start to level out. So yes, we do miss a little bit, and this is COVID coverage that we are missing more of. But there's a whole set of inner workings of government and newsworthiness that actually stays pretty constant, no matter when the training window is. So we are learning something that's a little bit deeper and more fundamental than just like what was popular yesterday. Okay, with that, thank you to all my collaborators. I am on the faculty market this year. I'm looking for computer science tenure track positions and postdoc positions, so please email me.
had a feeling that Ben Welsh was your contemporaneous Reuters journalist. I saw his picture up there, so that doesn't surprise me. Thank you, Alex. Just for way of context, the class that Alex helped me with was using a corpus of agendas from San Jose. We took a look at ICE contracts. California is a sanctuary state, and so that means that local governments are not supposed to have contracts with ICE for data sharing. And we found that Santa Clara County, the home of San Jose, had more contracts than any other county except San Diego in California for data sharing, which was kind of a big deal. And then Alex was able to help the students surface quotes from the county commission, basically saying that they were not sharing data with ICE even the same week that they were signing new contracts with ICE. So it led to a pretty good story. And it was because of having Alex in the room, being able to work with the students to think about how to evaluate all of that narrative text and plumb it, it was really useful. So I'll open it up for questions for Alex. Anyone?
Thank you for the talk, Kevin Preston, Syracuse University. Obviously the deep learning models and even the kind of model you were training, actually the kind of model you were training might be more interpretable, and I was wondering if it gave you insights into what made something newsworthy or not newsworthy, and whether that was then useful in suggesting how someone might approach a story.
Yeah, totally. This is a big unanswered question in this part of this research. We do have a topic analysis that we looked at that's in the appendix, but I think where we're really going to take steps in this direction is a follow-up project we have. We've expanded the scope across 7 different city councils across the US. So we've collected a ton more data, and we are looking at making these predictions explicitly based on explainable variables. So we're trying to basically say, this city council policy has these attributes, and then we'll directly make a prediction based off of those attributes, giving us way more explainability than we might get from just a black box GPT model. So I think you're right that this is a really important consideration. I would love to keep you in the loop for this work, so please reach out to me. I'm excited about kind of some of the early findings that we've been seeing.
Hey Alex, it's Brett Skillman from Bloomberg News, which we haven't chatted in a while. Given your experience at Bloomberg, and I'm sort of using that as a context, you're looking at city council meetings. Do you think, or is your experience that you might be able to expand that to other things? For example, financial documents and financial news.
Yeah, absolutely. Yeah, no, hey, good to see you. I think it's a little tricky when it comes to financial documents because, as you know, there's so much automated coverage. So when we ask, was this document covered in the news? Actually, probably most likely it was, but it was probably covered in an automated process. So we would probably have to look at which documents were covered by humans versus which ones were covered by machines. When did a human step in and actually rewrite an automated article? Because that happens a lot as well. Actually, we see Bloomberg News a lot that has a shared byline of a human and Bloomberg Automated, which is just an indication that the human came in and wrote the second or the third draft. So I think you could apply the exact same process, basically, of prior looking. I mean, I kind of turn it to you. How often do you think these kind of newsworthiness trends stay stable? In city council, what we have found is that, pandemics are always newsworthy. There was an Ebola pandemic before COVID, which helped us predict some aspects of COVID. discriminatory housing policy is always going to be newsworthy in San Francisco. There's certain repetitive themes that we see. I'm sure with your expertise, you might be able to point to repetitive themes in financial documents that would make the same thing true. It's not something I've really studied yet.
Okay, I think we're going to stop there, Alex, and move on to Joris. But thank you very much. And I think Alex is going to still be on the Zoom, just not on the big screen. So we can, if folks come up with a question at the end that they really wish, oh man, I still have to ask Alex, we'll try to pull you back in. And now we'll have Joris come up. And I think, yeah, Libby, thank you.
Yeah, of course, and thank you, Alex. That was really
which is a Dutch weekly magazine, kind of similar to the New Yorker. So I'm, well, kind of both an academic and a journalist. So today's talk will lean a bit more into the academic side, but it's also kind of inspired by the way I'm embedded within a team at de Amsterdammer. So anyway, I'm sharing a project today I worked on with Nick Diakopoulos, and our project explores how generative agents can support investigative data journalism by creating something we call a tip sheet. And a tip sheet here means a list of leads, in this case potential insights from large data sets that journalists then might want to pursue further, might want to investigate further. So the concept is relatively simple. We want to input a data set, a description of what's in the data set, the generative agents work together, do some analysis, and the output then is a tip sheet with some promising leads the journalists can choose to pursue further. And in this presentation I will show you how the system we designed works, some results we've seen, the next steps. Maybe first, what do we mean by agentic AI? So some talks already cover this, but just to make sure everyone is on the same page. Instead of like a simple back and forth in a chat interface, the idea of AI agents is that they can independently plan and carry out tasks for themselves, like executing code, interpreting the outputs, searching the web, book a hotel room for you. And this is actually quite similar to what ChatGPT nowadays does when you ask it to analyze data or to give you the most important news of the day. It isn't just the most probable answer anymore, but the result or the answer you're getting is the result of a series of steps it carried out itself behind the scenes. And so what's also really exciting about these AI agents is that you can also let them interact with each other, or you can make them work in teams where each agent has a specialized role. And this idea has been getting, as you also see here on the slide, a lot of attention lately. So for example, on the bottom left, there's this study on literary translation, where agents took the role like an editor, you had a proofreader, they even had like a virtual CEO, and they worked together to create the best literary translation possible, with some promising results. And so, partly also inspired by this project, our project experimented with like a similar team approach to create these tip sheets to help journalists find leads in complex large data sets, also because journalism too is often a collaborative effort. So what does our team look like? So the system we developed has 3 agents. We have the analyst, the reporter, and the editor. By the way, I should mention now, from now on, if I mention like the reporter, I'm not talking about the human reporter anymore, but I'm talking about the agent. About a reporter agent, not to get confused. And they interact with each other through like a series of prompts, and these types of prompts could be divided into two main types. We have the role-specific prompts and the task-specific prompts. And the role-specific prompts sort of act as the job descriptions of our agents. So they define their tasks. So in our setup, the analyst is responsible for conducting the data analysis and refining it based on the feedback. The reporter is responsible for generating questions, pushing the analyst for newsworthy insights, summarizing key findings, and then finally the editor is responsible for ensuring accuracy, making sure the work is bulletproof, and providing feedback on the work of the analyst and the reporter. We will share a link to the GitHub page, by the way, at the end of the presentation, so you can see exactly how these prompts look. But essentially, these role-specific prompts we're talking about are the system prompts, or what's frequently called the system prompts. And then, on the other hand, we have the task-specific prompts, also called the user prompts, although that's maybe a less appropriate name here. And they guide them to each step, and they ensure they focus on the right part of the lead generation process. Some technical elements: we built our system using OpenAI's Assistant API. We used GPT Turbo, and this was in May 2024. So, after we initialized our agents using the API, they interact with each other in 4 main steps, and I will walk you through these steps relatively quickly, but more information can be also found in the paper, which we will link at the end of this presentation. And so the first step is the question generation. We supply a dataset and a description of the dataset, and the pipeline is initialized with the reporter agent being tasked to inspect the data and to generate questions that could potentially lead to a story that are interesting to analyze in the journalistic context. The number of questions is actually a parameter in the system, but the default, or we set the default to 10. So the basic idea here is, okay, given a dataset and the description of the dataset, brainstorm 10 questions that will be interesting to answer for a journalistic story. That's just the first part. So we do this and then end up with a list of 10 questions. And then we move on to the second stage, where each question is tackled individually. So given a certain question, we ask the analyst, in this case, to draft a tailored plan to answer this question using the data. So we also supply the analyst with the data and the dataset description and ask it to draft a plan to answer this question made up by the reporter. This plan is then reviewed by the editor. He checks whether the methods are sound, whether it's sound logic to answer the question in this way, and any feedback is then implemented, step 2C, by the analyst accordingly. And so then we have a revised plan for a certain question, and we then move to the execution and analysis phase, which is the more complex phase. So once the plan is finalized, the agent conducts the analysis, interprets the results, and then the reporter agent steps in, and the reporter agent reviews the findings and checks whether they have potential to turn into a story, whether the findings are potentially newsworthy. And then we task the reporter to decide whether the analysis is suitable for publication. And it can choose between like 3 options. Either the analysis is suitable for publication, it requires further adjustments, or the question has reached a dead end. And if the reporter chooses for further adjustments, they send the analysis back to the analyst for adjustments, maybe suggesting like an additional angle or an additional analysis, and then the loop continues. And this feedback loop then continues until either we've reached a dead end, or the reporter agent is satisfied with the analysis, so to say. If that is the case, the reporter agent, so if the reporter is satisfied with the analysis, it summarizes the findings into a bullet point list, into a list of bullet points, hands it over to the editor. The editor then checks whether the findings itself are sound, provides additional feedback to the analyst. The analyst processes the feedback, and then the reporter summarizes the findings again into a list of bullet points. And then now we end up with a list of bullet points for each question, and then we ask the reporter agents to select the most important findings from these bullet points and put those in the tip sheet, and then reference. You can see here in the tiny example of the tip sheet, this is then the reference to the question it answered. So you can also retrieve back later, like what was the plan, what did it actually find, and so on and so forth. So quite an elaborate process to get to these tip sheets. And after some extensive prototyping, we really wanted to know, okay, does this actually give us something useful? So we wanted to put it into a more structural test. Does it actually give useful tips? Does this agent setup really hold up in the structural test? And so what we did was we picked 5 real-world investigative data journalism stories that had their data available online, and we ran the pipeline on this data. We chose these projects from a list of award-nominated projects, and we aimed, the projects are listed on the right, we aimed to get like a good mix of data types, insights, publication sources, publication types, and so on and so forth. We were in our selection, however, limited by the constraints of OpenAI's Assistance API, which doesn't allow for the execution of complex code, and this meant we had to leave out projects that needed either heavy computation, really large data sets, image analysis, or geographic data. And so we selected these 5 stories and then tested our agent pipelines against the baseline. And in this case, the baseline model was a model that didn't employ any specialized agents, so it was just an assistant working on the same problems, and didn't use any of the feedback loops we saw. So essentially this means step 2 and 3 are replaced by a more simple prompt saying, okay, just analyze the data and summarize the findings. And then for both the baseline and the generative agents pipeline, we ran each story 3 times on the dataset with 10 questions, resulting in 300 tips in total. And then we manually coded these tips, manually evaluated these tips using 3 metrics. First, we looked at validity. Is the tip a reasonable inference from the data? The second is potential newsworthiness. Does the claim have the potential to be newsworthy? We use potential newsworthiness here as a metric because it's, Alex also said, like, it's tough to define newsworthiness across different contexts, different institutions. So instead, we just assessed whether a claim could be considered potentially newsworthy or not. And then third, because we used real-world investigative stories, we were able to compare the claims found by the models with the original articles. And so we asked ourselves, okay, how many of the claims the model found were also in the original article, were also in the original reporting themselves. These are the results. They were relatively promising, also showed a few challenges. Agents scored relatively well on validity with a score of between 80 and 90%. Struggled, that was really clear, with more complex tests. So there was one project that required multilingual text analysis, and we saw a significant drop in validity. That is the headline story. What we also saw is that in terms of potential newsworthiness, we saw that the generative agents pipeline consistently outperformed the baseline across all stories. So the potential newsworthiness in the tips generated by the generative agents pipeline was considerably higher than in the baseline. And then in terms of precision, we found that only 1/3, or in general 1/3 of the generated findings were also included in the original reporting. And this also really shows that human editorial judgment is still crucial, that the AI can suggest ideas, but it's important that humans choose which ideas really develop into stories. So looking ahead, there's a lot we can do to further test and improve this system. One major improvement would be to use non-proprietary models that don't have the limits of the assistance API, so this could make the system also more flexible, allowing agents to handle larger data sets or work with media like images and videos. We had to include quite some projects now, and if we were in control of how we let the agents interact with the code, that could help us also include more complex projects. We also now only looked at the baseline model, or we now only pitted like a baseline model, a general baseline model against the full pipeline. But we're also really interested in how like these small little tweaks in the system prompts, in the knowledge bases, in the feedback loops would improve the performance of the models, and how we also can test this in a more structural manner. So not only comparing the baseline to the generative agents, but also what if only an editor and an analyst work together, or what if only what happens when only a reporter and the analyst work together, or what if we get rid of a certain feedback loop. That will be interesting to test as well. And one area we're also really excited about is giving journalists more control. Right? So right now we just input a data set and output is tip sheet, but we also see a future, or we can imagine a future where journalists guide the system more directly. For example, in shaping questions, giving real-time feedback, refining the analysis themselves. And then finally, also circling back to Julia's talk this morning, one really important limitation of our evaluation is that we totally omitted the data collection part. And we supplied the agents with totally clean data sets. And well, speaking also as a data journalist, clean data sets are very rarely supplied to me. There's a lot of manual labor behind the scenes that we also just didn't look at. So to complete, the system shows some promise, but it really should only be intended for now to provide journalists with interesting leads, and not something that could stand on its own. Turning data into a story is something that should remain firmly into human hands. And so for anyone interested in learning more, I've included some researches on this slide. You will find a blog post, the paper itself, and a link to the code, which contains also all the prompts. Feel free to explore them. If you have any questions, like to discuss potential collaborations, also please reach out, email on the top. And thank you for your time and your attention today.
I'm going to just say that there's been so many times I've been in a newsroom with, a reporter, a data journalist, and an editor, all trying to figure out the story. This seems to model that. It's really interesting.
I'm curious, with results you reported, if the system was able to come up with novel, newsworthy ideas, or was basically the newsworthy ideas were the ones that were in the original reporting, and the new ideas were not newsworthy.
Yeah, thanks so much for the question. So we did find quite some tips that we labeled at least as potentially newsworthy, that weren't included in the original report. So for example, if you look also at the evaluation here, we do see that if we look at the newsworthiness, we labeled about 66% of the tips as potentially being newsworthy, whereas only 1/3 of the tips were also found in the original reporting. So there is some difference between the tips, or there are quite some tips actually we labeled as potentially newsworthy, but weren't included in the original reporting. Yeah, something I also found is that it really, was related also to like editorial focus. I think it was this story about Facebook ads and the or political ads on Facebook in Taiwan, and we found that the original reporting mainly focused on like the general statistics, so who spent the most, which parties spent the most, which politicians spent the most, and then the agents would more, somewhat also prefer a more general analysis. So what's the cost? What's the relation between the costs and the reach you're getting? And then they found, okay, some parties pay more for the same reach. And so that, I think that was also an interesting difference in, and it highlighted how editorial judgment still really matters.
I actually have a related question. I was wondering if on the generated findings, if you went to the reporters or editors of the published work to see if they had also surfaced those same findings and tried to report them out. I mean, one of the things that happens in an investigative project is you have to focus, and so you decide not to report out a lot of things. Doesn't mean they're not newsworthy. So I was curious about that.
That's an excellent point. That's also why we also didn't want to focus on precision alone. So we first thought only looking at precision because that was a measure that could also be potentially automated and didn't require any manual annotation. But after long discussions, we also figured that there's a lot you leave out, and I know it myself as well. A lot of findings that are potentially newsworthy, you have to omit them because there's limited room, and usually there are some cases where you can find like related findings or findings that were omitted, but usually you can't find these findings. We haven't been to like journalists, or we haven't talked to the journalists involved in this project, but that would be really interesting to do as well.
Any questions?
Hey, thanks for this. This is really cool. So one question I did have was about the data description that you feed into the model. Did you find any sort of difference between the performance if that description was more in depth or longer, or were there critical elements of that were important to get a good result?
I'm getting my exercise.
We did experiment with the data description in the prototyping phase, but we didn't structurally test for it. In the prototyping phase, we did find that, well, if you don't explain what a certain column means and the column doesn't have an obvious name, doesn't have an obvious name, there is a larger probability that these agents might hallucinate like the meaning of this column. We did find it to be really important to be relatively elaborate about, well, what does this column actually mean, or what does it actually measure? I think that would also be an interesting thing, again, just a little tweak to structurally test. How does this data description matter? Also in the sense that we provided, I didn't explain it here, but we provided with both like, okay, what does do these columns means, but we also provided with like a general description, which are like 2 to 3 sentences. So this is a data set collected from this source. It's about this. It's well, gathered in this time period of time. I'm also interested in seeing how, well, small little tweaks in this data set description would, well, affect the output.
Any other questions? Yep. I'm gonna just like hand the microphone this way.
I'm curious if you tested this like agent approach with any other journalism tasks or anything that's more like discrete than this kind of open-ended discovery. I'm also wondering who you found is the least useful agent in your chain. Is it the editor? My secret fear is the editor made everything worse.
I was thinking that would be the one that would be cut out, would be the editor.
Well, yeah, I can say that the editor made the answers by like the reporter a lot more elaborate, and then we have to we task it to turn it back into like a 1-sentence tip. So yeah, I'm also like curious what happens when you leave the editor out. We didn't try it on any other task. Like besides like these open source data sets. Yeah, it would be an interesting avenue.
Did you think about ranking your tips in terms of newsworthiness? Like, you know, as opposed to just bullets, but like, here's, you know, like when I think about a journal, like, I always have like, here's my minimum story and here's my maximum story. So like, you know, I can go get this one pretty easily. I don't know, something along those lines. I don't know.
Yeah, but that would also be an interesting addition to like this pipeline. Yeah. No, we just say like, give me the 10 most newsworthy elements, and it's usually ranked based on the question number. So it does 10 questions, they are numbered, and then usually the first tip is the first question number. But it would be maybe also useful for the journalists to rank them by newsworthiness, and add that to this pipeline.
So you mentioned that the first step is to come up with questions, and you only feed the description of the data set. And you know, a lot of these data sets are like huge, and they contain a lot of granularity, you know, like a lot of details that these stories might embed in these details. And the question answering agent is at the first step, and it proposes a question that all of the other agents has to answer, right? And that question doesn't change over time. And so could it be possible that when you discover like interesting details in the data set, you might consider changing the question?
Yeah, so I think that it doesn't drastically change the question. So the overall question generally remains the same, but it is more or less embedded in this stage. So the reporter assesses the work of the analyst, and then when it doesn't consider it to be newsworthy enough, it does suggest like additional angles. And it can also suggest additional angles based on like the findings of the reporter. So, suggest additional angles based on the findings by the analyst. And so they interact with each other, and then it could be possible that the focus of the questions changes a bit. It's not like a drastic new question, but it's an additional angle in the data set.
I think that might be all we have time for, but thank you very much, and thank you, Alex.